Despite all of its positives, Adam still has some pitfalls, which is that if we apply L2 regularization, it is applied directly to the gradient. So when it is applied to the gradient, and then we perform bias correction as well as the adaptive learning rates, what will happen is that it causes a non-uniform regularization, which means that we have some parameters that might have too much regularization and some with too little. So it basically renders our regularization process kind of redundant because it still leads to suboptimal generalization. So what AdamW fixes is that it applies weight decay as a separate shrinkage of parameters after the update itself. So let's look at mathematically how it is done. So if you look over here, the regularization is applied directly to the gradient, right? So we have our gradient here and our regularization term here, and then our updated G prime, which represents the updated gradient with regularization. After you pass it through the bias correction and the adaptive learning rates, what will happen is that the regularization is no longer uniform, right? Because it gets scaled by the adaptive learning. However, AdamW does it differently. It keeps the raw gradient, so we'll continue to do bias correction and the adaptive learning rates without being affected by regularization at all. However, where do we apply the regularization then? We apply it directly to the weight decay. So we'll apply it directly to the weight parameter instead of to the gradient itself. So this helps us to consistently and uniformly regularize across the parameters.